So they knew whenever one thing was being loaded. The problem here is that init does know when anything is being loaded. But after that, for example, you have a library here. For example, libc. Now libc does not know, for example, if you start Firefox, libc does not know that. How is this C going to measure that? That is where a slight architecture change comes into this IMA domain. What happens is, kernel is responsible for loading everything. Right? The kernel is responsible for loading everything. In kernel, you have several functions which are called whenever you want to load a library, or if you want to load a simple file or an executable. Whenever you want to do that, you have certain functions. For example, file _mmap. That is called whenever you want to load something, right? That is memory mapping of file. So in those places, hooks are placed. ls and hooks. You don't need to know right now what ls and hooks are. But there are certain hooks which perform the same loading, the same recording functionality. Very simple case. Let's say you type ls. It goes to the shell, it goes to the kernel, do several steps. When it gets to the kernel first measures the hash of the ls binary. It saves it or records it in CCR10 and then executes that. It does not execute ls directly. Fine. This whole thing goes on forever, as long as the system is up and running. We have several things here. I'm not going to write them down, but it's a long list. You have several libraries, several executables. If you type man, that goes in. If you start Firefox, it starts a billion libraries. If you start Eclipse, it loads JVM, the JVM loads from certain libraries, and everything is loading something, right? And everything goes into this list, right? I'm calling this a list, but I haven't actually declared it as a list. We come to that in short. And the exact numbers are given in the DTM specification. They are stored in 3 or 4 different PCRs, not in a single PCR.
और bootloader के बाद जो होगा वो भी PCR.
That is in PCR10. That is IMA, and IMA uses only PCR10. The bootloader, the customized bootloader, is called Trusted Grub that IMA people have provided us. It's called Trusted Grub. The same grub has been modified to improve this measurement and loading. We do a little simplification. We have the kernel. It loads something, for example, let's call it ls. Report means that it does several things. It puts the value in PTR10, records the value in PTR10. We still have talked about how the actual recording is done. It records it in PTR10, number one. Secondly, it puts the hash in a stored measurement log. The stored measurement log is a file in the security file system of Linux. And we're talking on nothing about Linux here, because this is an implementation media. The stored measurement log is in this kernel security, that is the security FS of Linux. You have in its simplest form CPR number here, the path and the hash. And whenever the CCR10 is extended, whenever anything is recorded in the CCR10, an entry is added here. right? And this whole list is maintained as long as the current system session is in place. When you reboot, this thing goes away because it's in memory. But as long as you have the system, this thing is here. And the PCR recording is going on at the same time. This is the chain of loading and measurement. Whenever something is loaded, it is measured. Whenever something else is loaded, it is measured too. What's going on is you are creating a chain here. You have the TPM. It's invisible inside the top. You have the BIOS. You have several ops. Then you have the bootloader. Then you have the kernel. And then you have application. This thing, as you can see, looks like a chain. Right? And this is what is called a chain of trust. This is called a chain of trust because first this is a chain. There is a link of measurement involved. If you trust this thing, that this is correct, then you must trust that the TPM will measure the BIOS before passing the control. Because that is its behavior. That is what you expect it to do. And if this BIOS can be trusted, that means that it will measure this op. And if this op can be trusted, it means that the bootloader will be measured. And you will have all those measurements. Right? So this is basically a chain of trust. There are several issues in this argument. Right? There are a lot of ifs. I am saying that if the BIOS can be trusted, the TCG argument says that if you trust the TPM and the BIOS is the same that you expect, then the BIOS can be trusted. We don't agree with that. That is why we bring dynamics into behavior. But the specs say that if the TPM can be trusted and the BIOS is the same that you use, for example, in another scenario. Right? If you know that the Dell Latitude D830 BIOS has this specific hash, and the TPM measures this BIOS and tells you that this BIOS has this same hash, then you can trust it. That is the argument provided by TCG. That if the hashes are the same, then you can trust that BIOS to act as you wish. Right? Because you use that BIOS to use. We don't agree with that. We being the people who have been working on application at the But right now we're talking about it. So this chain of trust is established using the hashes saved in TCR10 on the different TCRs. We won't talk about this portion here. We start with this because that is what IMA is and that is basically what we're concerned with. We're concerned with the platform, the operating system that's running. We're not really concerned about the hardware that is present in the system. That is important. That is important also in the sense that the chain of trust is here. The chain of trust is not here. We cannot start from this source. We have to start from this source. Right? But in our argument, in our discussion, we only start from there for specific. Right? So we have a chain of trust, we have a PCR, we have a stored measurement log that is the SML, but how do they fit together? How do you take the SML and the PCR and say that the SML is correct and that I can trust the value of PCR or that these two are the same? How do we make all these arguments? We make these arguments using several cryptography constructs. Let's start with those. First of all, we need to understand how one PCR is used for saving so many measurements. We talked about the SML, it has a lot of hashes. How do those hashes all get into one PCR? Here now, let's say you have the bootloader. You take the hash. That comes to, for example, 1. Right? You need to measure the kernel now. Let's see, the hash of the kernel itself is 2. Now, one important point to note here is that, let's take another place. We have init